Hello everyone, welcome back to Physical Learning Point. I am Himani Dikshit and I am once again in front of you all with some new concept and tricks related to nuclear and particle physics. So I hope you all are doing well, and after a so long time I am now once again uploading a new video based on the concepts of nuclear and particle physics. But now I will try to upload videos in continuation so that I can cover maximum part of the syllabus as much soon as possible. So let's get started. So in the last video I have told you about the calculation for the magnetic moment of a nuclei, that how you can calculate the magnetic moment of a nuclei. And I have also told you that how you can calculate the magnetic moment of any nuclei for even case and even odd or odd even case. But since it has been a long time, so I will again revise it for you all so that we get in a continuation and get better understanding for all the concepts. So for calculation of magnetic moment of a nuclei, there are three cases. We have three cases. That is, either our nuclei contain even number of protons and even number of neutrons. So in that case, we can say that it is a case of even nuclei. So number of protons are even and number of neutrons are even. In that particular case, the magnetic moment of a nuclei is always zero. We don't go into deeper for more calculation. We don't need to do anything. We just simply get to know that for both even number of protons and even number of neutrons, our magnetic moment is zero. In second case, we have even odd or odd even nuclei. Means either we have even number of protons or odd number of odd number of neutrons, or even number of neutrons odd number of protons, means vice versa. So in that case, we have unpaired we have again two cases. That is, we have unpaired proton but paired neutrons. So in that case, we need to calculate the magnetic moment of a nuclei based on these two formulas. Means if it is satisfying L plus half rule, then we have to calculate magnetic moment with using this. And if we have L minus half, J value is L minus half, then you can calculate magnetic moment using this formula. Again, if we have unpaired neutron but paired electron, means unpaired neutron means odd number of neutron but even number of proton, then we can calculate the magnetic moment of a nuclei using these two formulas. Means if J value is satisfying L plus half, then we can calculate magnetic moment using this formula. And if we have the J value is satisfying this L minus half rule, then we can calculate magnetic moment using this formula. There is one another case in which both the proton and neutron are odd in number. So in that case, first of all, we need to calculate the magnetic moment for odd proton using these formulas, which one is suitable for that particular case. And then we need to calculate the magnetic moment for a neutron using these two formulas. And after calculating both the two, we just sum up those two magnetic moments and we get to know about the total magnetic moment of that nuclei. Okay, so this is all over the total concept in order that you need to know in order to calculate the magnetic moment of a nuclei. But once you get to know this formula, you can't be able to calculate the magnetic moment, because you have to know the value of J, you have to know the value of L. Then how you can get the value of J and L? So for that, you need to know about the sequence of energy levels. This I have already told you in my previous video, but since there is a discontinuation in between those last lectures and this one, so I just need to get it revised once again. So these are the energy levels, subshells means filling of subshells of the nucleus of an atom. So the filling of subshells like will be done like in this way: S1 by 2, P3 by 2, P1 by 2, D5 by 2, S1 by 2, D3 by 2, F7 by 2, P3 by 2, F5 by 2, P1 by 2, G9 by 2, G7 by 2, D5 by 2, H11 by 2, D3 by 2, S1 by 2. And these are the respective number of nucleons. Means in this subshell 2 nucleons get filled. In this 4 nucleons are get filled. In the similar way you are going to fill your nucleon in these subshells. So you have to memorize it very carefully in order to calculate the value of J and L. Okay. Now first you have to calculate the value of J and L. So how you can calculate the value of J and L? First of all, you have to memorize that splitting energy levels, okay, and energy level sequence, and then after that I can tell you how you can calculate the value of J and L by giving an example. Okay, so let us take an example. I have a nitrogen with 7 number of protons and 8 number of neutrons. Okay, this is the atomic mass. So number of protons are 7 and number of neutrons are 8. So which one is odd here? That protons are odd here. So we don't need to consider this. We have to consider that part which contain odd number of nucleons. So we have to calculate the value of J and L for this one. So number of protons are 7. So start filling those nucleons in the subshell in a similar way. S1 by 2 that get filled by 2 nucleon means 2 proton, and then P3 by 2 contain 4 protons, and then the last one P1 by 2 contain 1, 2 4 6, then 1 7. Okay, so the last subshell is this one. Okay, so these are the filled subshells and this is unfilled, means partially filled. So we have to consider this one to get the value of J and L. Now how you get the value of J and L? This one, this is either is a S, P, D, F. Which one orbital is giving here? This will give you the value of L. If it is written over here S, means L value is 0. If it is written over here is P, then L value is 1. D, for D L value is 2, and for F L value is 3. So what is written over here? P. So the L value is 1. Okay, L value is 1. And for J you have to consider this value P1 by 2. So 1 by 2 is representing the value of J. So J here is 1 by 2. In a similar way you are going to get value for all other cases. So what you need to do is, first of all, start filling your subshells with the number of protons or the neutrons which one is odd, and after that the outermost subshell will give you the value of J and L. So in this way you get to know about the value of J, L and S as well. Okay, S, you can also calculate the value of S by this one. This one is representing the value of S. So I think you will get to know how you can calculate the value of J and L. So after getting the value of J and L, you need to calculate the magnetic moment. Okay, so I have already told you the formulas. So now here I am taking one example to tell you that how you can calculate the value of any magnetic moment of any nuclei. Okay, so let's take an example of carbon. So carbon here is 6 and 13. 6 here is proton and 13 is neutron. So which one is odd? Neutron is odd. So don't consider about protons since it is even in number. Just consider about the neutrons. So start filling your subshells in this way, similar S1 by 2, P3 by 2, P1 by 2. Okay, so 4, 2, 6, 1, 7. Last one is this is the last one. So here we can get the value, from here we can get the value J is equal to half and L is equal to, since here it is P, so L is 1. So now you get to know about the value of J and L. What's the next? The next is we have to satisfying, and what is the case here? Neutrons are odd in number, so we have to take the case of unpaired neutrons. So again, in case of unpaired neutrons, we have two possibilities. Either we have L plus half or L minus half. So which one is satisfying here? You have value of J and L. So try to satisfy your value with these two cases. Which one is satisfying? So I think this one is satisfying. J is half and L is 1. 1 minus half is half and J value is half. So this one is satisfying. Okay. So you have to go with this formula. Now calculate your magnetic moment using this formula, 1.9135 J by J plus 1. So J here is half. So 1.9135 half and by half plus 1. Okay. Now calculate this value and tell me what is the total value of magnetic moment of this particular case. Do write in the comment box the value of this magnetic moment of this nuclei and tell me that whether you get to know about this concept or is there any doubt or any question related to this concept. You can write in the comment box. I will give reply to that. Okay. So in the next video, I will take some more examples and tell you how you can calculate the magnetic moment very easily using these concepts and tricks. So I hope you like this video. So do like and share share this video and do subscription so that I can upload many more videos with some new concepts and tricks. So that's all and thank you.